Let's take a look at question number 7. A 500 milliliter sample of water has an initial temperature of 95.0 degrees Celsius. What will the final temperature be after 1500 joules of energy is removed? Okay, so as always, first thing, Q equals MC delta T. And Q equals M equals C equals delta T equals, and delta T is equal to the final temperature minus the initial temperature. Okay, so 500 milliliters sample of water, so it's 500 milliliters. Well, we don't have volume here, but we have mass, and we know the density of water is equal to 1 gram per milliliter. So our milliliters cancel, so it's equal to 500 grams. So our mass is 500 grams. And we'll jump here and we'll come back to the temperature in a moment. After 1500 joules of energy is removed, so the Q is going to be 1500 joules. Right? C is the specific heat of water. On the reference table, 4.18 joules per grams times Kelvin or degrees Celsius. All right, so our delta T in this case is going to be equal to the final temperature, which we're looking for. So that's our final temperature, minus 95 degrees Celsius. Yeah. Now, one other thing to think about is the Q. 1500 joules of energy being removed. Right? That's going to have to be negative because energy being removed means it's exothermic. It's giving off energy. So here, we're going to have to solve for delta T. So if we divide both sides by MC, and they cancel, we end up with delta T is equal to Q over MC equal to minus 1500 joules divided by 500 grams times 4.18 joules over, so we can just sneak it to the top here, grams times degrees Celsius. Grams cancel and joules cancel, and we're ending up with a degree Celsius, which is our delta T. So now, if I can plug this into a calculator, and let's see, we'll say 1500 divided by 500 divided by 4.18, and we get 0.718 degrees Celsius. So it's not really that much. So our change in temperature, delta T, is equal to 0.718 degrees Celsius. So all that water gives off quite a bit of energy, and it doesn't cool off that much just because the specific heat of water is so large. So our delta T is equal to the final temperature minus 95 degrees. So minus 0.718 degrees Celsius is equal to our final temperature minus 95.0 degrees Celsius. So we add 95 to both sides, cancels on this side, 95.0 degrees Celsius here. So we have 95 degrees minus 0.718, and we end up with a final temperature of 94.3 degrees Celsius. So we removed all that heat and the temperature only dropped a little